Okay, lesson 8, the remainder and factor theorem. All right, so we're going to use something called synthetic substitution here to do these. You can read the definition of the remainder theorem. It's a little bit complicated, okay. It just has to deal with whether or not we have a remainder or not and how that remainder can be used to determine some math. Okay, jump into an example problem and figure out exactly what we're doing. Problem number 1. If the function as defined by x is all of this, we want to find our answer when f is -2. So what this is saying is, if the function is this, right, when it's defined by x, well, what is the answer when x is now a real thing, when x is a -2? And we can do this 2 different ways, and it outlines these ways actually pretty well up here. The first way is something called synthetic substitution. Okay. So if we were going to do this, we would say, okay, the -2 is going to be like our synthetic division. That's why it's synthetic, right? It goes up here. And then we're going to take the coefficients and we're going to place them right here. We're going to do the whole thing where we drag down, multiply up, add down, multiply up, add down, do the whole thing. And the answer, after we do all of that stuff that we know how to do, is 8. Okay, the answer is the remainder. That's totally a way you can solve this. It just seems like more work because the other way is so much better. Over here, direct substitution, method 2. Again, think about what the question was saying. It was saying, okay, originally the function is defined by x, and it's this. So what happens if now, instead of x, we have -2? That means every place we see x, we are going to, in a bubble, in parentheses, put that value. And this is great because we don't even need to do this longhand. The calculator will do this exactly for us as long as we're there. So f of -2 equals 8. This is a much cleaner, much faster way. The other way totally works, but I personally would not do that. So down here, it says, use synthetic substitution or direct replacement to find f of -5 and f of 1/2 for each of these. You're going to do it twice. It's not a big deal. So I'm going to take this function, -3. That's where I see x. My first x that I care about is -5. That is being squared. Okay, so I'm going to directly put it in a bubble. Plus 5. And now I'm going to have an x. And I'm going to finish it up with -1. Okay. So that's what f of 5 is. I guess let's put that over here. F of -5. Okay, it is that. Now, let's go to our calculator and let's do this. I'm not going to remember what this looks like, so I'm going to have to do some bouncing back and forth. This is going to be good content. So let's go here. I immediately forgot what it started with. I couldn't even remember the beginning number. Okay, so I have my calculator. I'm going to go here, -3 parentheses -5 squared. So I'm going to do -3 parentheses -5, and I'm going to hit the squared button. Okay. After that is plus 5, -5, -1. Plus 5, -5, -1. Okay, so I'm going to type it exactly how I see it. That's a -5. Do I want that -5 there? I think I do. -101 is the answer. I could have done long division. I could have figured that whole thing out. Apparently we're talking about absolute value over here. But the answer here I'm going to do the exact same thing now, but I'm going to do it with 1/2. And however you want to do this, f of 1/2 equals -3. However you want to do this, it doesn't matter. -1/2 in a calculator, sorry, just 1/2 in a calculator is 1 divided by 2, but also it's the same as 0.5. So just for calculator friendliness, I'm going to do 0.5 as I direct substitute squared plus another 0.5 finish it up with a -1. Okay, it's gonna bug someone that that's not the same color. Okay. I'm gonna go back to my calculator, and actually it's nice because it's there now. So I'm gonna do -3, and instead of -5, I'm gonna have 0.5. Close it, square it, plus 5, parenthesis, 0.5. Close it, -1. And that is 0.75. If I wanted to, I could hit math, enter, enter, and I could see that that is 3/4. So when it is defined, when f is defined by a half, that's going to equal 3/4. And that is a super clean and super easy calculator way to do this. You can do it by hand, sure, you could do it by direct substitution, but I personally wouldn't. I would just let the calculator do the work, and as long as you do your bubbles correct, you'll be fine. Do I even need to do more examples? Probably not, but someone's gonna complain, so I will. What do we got on this page? Okay, more stuff. All right, so we're gonna be here. Let's do this one with a negative in front, because that's maybe scary. No, we just had a negative in front. That person, calm down, okay, it's okay. Over here, this number is 4, and that's scary, and that's big, so we'll do that one. We'll like, those freaking out people can chill. Over here, boom. Tell I've recorded like 5 lessons in a day because I'm starting to get real tired. Okay, now we're talking about -5 and 0.5. We're gonna do the same thing. So as I rewrite the function, f defined by -5 is -5, and that thing is going to be risen to the 4th. Plus 11, there's another x, -5, that one's being squared, -1. Okay, so in my calculator now, I'm gonna try to remember this, -5 to the 4th, over here, boom. In my parentheses, -5, close it. Now, how do I raise something to a 4? Because I have the button for the square, and that's nice, but if I wanna raise it to anything else, above this divide button, a little up arrow. Yours will look different than mine. Yours will literally might have a giant arrow that puts in there. We're gonna type 4. Okay. I'm gonna move to the right so I'm no longer typing in the exponent. Yours might look different. It might look like this. Oh. Goodbye, abs. That's what I said after college. Okay, it might look like this. -5, up arrow, 4. Totally fine. All right, let's finish the rest of it. Plus 11. Plus 11, parenthesis, -5. This one is being squared, and I think it was -1. Just like that, parenthesis and all. 899. Okay, sure, why not? Could be anything. Do the same thing, f of 0.5. 0.5 risen to the 4th, plus 11, 0.5 squared -1. Okay. It's a terrible color scheme I have going on. Okay, do the same thing, plug it in. 0.5, close, raise it to the 4. And if you have a calculator like this, you need to tab to the right so you have big print now. Plus 11, close it, 0.5, that one's being squared, -1. Sure, I could write that decimal. Or I could put 29/16, okay. Doesn't matter to me. Okay, easy enough. We can do this. Next page. Okay, the factor theorem. Okay, so this is more synthetic division. So if you're good at synthetic division, fantastic. Now what we're doing here is we're just determining if the thing we are dividing by is a factor. And if it is a factor, we won't have a remainder. So Question. Is 5 a factor of 35? Hopefully you know that it is. But if I was going to do this, it'd be like 35 on the inside, 5 on the outside. It would go 7. 7 times 5 is 35. I would subtract, and I have 0 left over. 5 is a factor of 35. Okay. Slightly different question. Is 3 a factor of 35? 35 divided by 3. Well, 3 goes into 3 once. Times 3, multiply, go away, 5. 3 goes into 5 once, multiply, subtract, I'm left over with 2. 3 doesn't go into 2. I have a remainder of 2. So, no, 3 is not a factor. So we are determining if things are factors, meaning they don't have a remainder, or if they are factors, no remainder. If they're not factors, they do have a remainder. It's late in the day. Okay, it is. So, blah, blah, blah. Right here. We have been given a polynomial and one of its factors. Find the other factors. Okay. Remember, a factor is just a thing that multiplies. That's like saying I give you 42 and one of its factors is 2. Find the other factors. So you'd be like, okay, I'm going to divide this into that to get 21. What are the factors of 21 now? 3 and 7. I was given one factor, I found the other 2, because if I multiply all of these together, I get back to 42. Is this making sense? I hope so. I'm not here. I'm at home with a baby right now, probably. Nothing's making sense to me. All right, this equals 0. A special number, boom, it goes here. Take my coefficients. I don't think I'm going to have any placeholders. 3, 2, 1, none. 1, 1, negative 10, 8. Okay, so the goal should be not to have a remainder. If we have a remainder, we probably messed up, meaning I messed up, because you're not here. I'm here alone in a room doing math. 1 times 2 is 2. Add down. 2 times 3 is 6. Add down. Multiply up. Add down. No remainder. Good deal. I started with 3. I should have 2, 1, none. Clean it up. X squared plus 3x minus 4. Okay, this is the answer if I just wanted to divide, but this is like that 21 that I just had. I gotta factor this now into its things. So I'm gonna take this, and I'm gonna put it into the cross. We're at a times c, and then b. My a term here, 1 times c, negative 4. My b term is just 3. What two numbers multiply to make 4, add to make 3? So it's going to be 1 and 4, right? It's the only way that makes sense. So it's going to be positive 4 and negative 1. Cool. These cloud numbers go into this form, where I have 2 bubbles with an x at the beginning. I'm going to drag and drop these, minus 1, 4. And that is my factored answer. Given one factor, find the other 2. Nicely done. Thanks, me. Down to number 3. Okay. 1, 15, 71, 105. Take the first thing, drag it down. 1, multiply up, add down, multiply up, add down, multiply up, add down. Okay. I started with 3, I should have 1 less. 2, 1, none. No remainder. Love to see it. X squared plus 8x numbers multiply, let's see, a times c, that's 15. This is 8. What two numbers multiply to make 15, add to make 8? 3 and 5. These numbers go into a form. Plus 3 plus 5. That's it. Are any of these any kind of harder? Someone's going to complain if I don't do another. Someone's going to be, you didn't teach me. Oh gosh, okay, that's the next lesson. That's the final lesson, I think, maybe. All right, 6. 6 maybe is scary. I don't know, it has a 40, and that's like 2 digits. That one has a 72 in it though, and 72 might be scary. I don't know. We're gonna do 6. Okay. Special numbers, -4. Do I have any placeholders? 3, 2, 1, none? No. 3, -1, -62, -40. Drag the first one down. 3, -12, -13, 52, -10, 40, 0. Okay. We got 2, 3, so we should have 2, 1, none. Uh-oh, SpaghettiOs, I got a problem. 3x squared minus 13x minus 10. Goodness gracious, great balls of fire. I'm really hoping by the time you see this, you know how to factor things when a is bigger than 1. Because if not, this is about to make not a lot of sense. Okay. I am not going to use the quadratic because I need to factor this. I want to get an answer. I don't have a lot of room. So what I'm going to do is I'm still going to start with my cross. I have to. Hopefully this is new or not new to you. A times c, b. My a is 3, my c is -10. -30. My b is -13. Okay. I still want to find numbers here. I'm pretty sure I can do that. When I see 30 and 13, that my brain immediately goes to 10 and 3. I can make this happen with multiplication, I can make that happen, but I don't think that'll work for the signs because one of them needs to be negative. And if 10 is negative and the 3 is positive, that's not going to work out for this. So it's actually going to be 2 and 15. It's going to be -15 and +2. Those are the two numbers that will work. This times this is that, this plus this is that. Okay. So what I'm going to do now, and what hopefully you know, is that these numbers are secretly the entire time, they've been the B term. Okay, they've been this. This is how this works. I combine those to get there. So I'm going to rewrite this problem now, 3x squared, but I'm going to replace this with these, -15x plus 2x. Okay. Same thing, right? I've written the same problem. I get -13. I've just wrote -13 a different way. Why do I do this? Why do I make the problem harder? So I can do what's called factored by grouping. I'm going to take each of these 2 pieces of 2. I'm going to chunk them off. And I'm going to say, what is the most that these 2 things have in common? Looking right here, I see that both of these terms have a 3, and they both have 1x to give me. So if I'm going to factorize this, in fact, I will rewrite this. Well, I'm not going to rewrite it because I wrote it so nicely there. But I'm going to do the work for it up here. The most I can pull out of both of these terms is 3 and x. If I do that, if I take a 3x away from 3x squared, I'm only going to be left with one single x on the inside for that term. So when I pull out, I divide. So I'm going to divide this by a 3 and an x as well. That's going to give me -5. But this only had 1x to give, so if I pull out the x, I'm going to be left with that. Now, what is the most that these 2 terms have in common? I see a 2x and a 10. Well, both terms don't have an x, so I cannot take an x away from both. So I can't do that. I only want to take out the most they have in common. I can take a 2 away from a 2, and I can take 2 out of 10. If I take 2 out, what am I going to be left with? Take a 2 away from 2x, I'm left with x. If I take a 2 out of 10, remember when I take stuff out, I divide. So this divided by 2 is -5. Quick check. If I did this correct, my bubbles here are gonna match. They do. Good. So my final answer, it's gonna be one of the things I have 2 of. Just one of those things. I'm gonna have it one time. What is the other thing? Whatever I pulled out. 3x and a +2. This is pieced together from this and this. Factor by grouping. Hopefully past me is good and taught you this.